Okay. So even integers that can be expressed as x equals 2k, where k is an element of z. Okay. Odd integers that can be expressed as x equals 2k plus 1, where k is an element of z. K parity, okay, odd or even characteristic of a number. Okay, so if it's odd, it has odd parity. If it's even, it has even parity. Rational numbers, okay, functions, or sorry, not functions, fractions. Fractions and terminating decimals. Okay, can be expressed as x over y. Okay, an integer x divides y, divides an integer y if and only if x is not equal to 0 and y equals kx for some integer k x with a line y, okay, it's kind of a bar, x bar y denotes x divides y. Okay, if x divides y, then y is a multiple of x, and x is a factor or divisor of y. X divides y with a line through it, okay, means x does not divide y. And x is not divisible by y. Sorry, y is not divisible by x. Okay, prime number a positive integer that is only divisible by 1 and itself. Composite number is a positive integer that is sorry, a positive integer n divisible by an integer m, okay, at least one integer m, such that one is greater than one is less than m, but that's less than the number itself, m. Qualities. If x and c are real numbers, then exactly one of the following statements are true. Okay. X is less than c, x is equal to c, or x is greater than c. Okay. Okay. Exactly. These are strict inequalities. Okay. Okay, the values of x and c can also be related by the symbols x, well, let's just do the symbols less than or equal to and greater than or equal to. A, x greater than or equal to c, or x is greater than or equal to c if and only if x equals c or x is less than c. Oh, sorry, x is greater than c. And thus, x is at least c or x is greater 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 than or equal to C. Okay, B. Okay, X is less than or equal to C if and only if X equals C or X is less than C. Thus, X is at most C, or X is less than or equal to C. Okay, if X greater than C is false, then X is less than or equal to C is true. So these are the complements of these. If X less than C is false, then X greater than or equal to C is true. Okay, so they're complementary statements. Okay. Okay, if X is greater than C is true, then then X greater than or equal to C is also true. Okay, because if it's bigger than C, then it's also bigger than or equal to C. If X is less than C is true, then X is less than or equal to C is also true. A real number X is positive if and only if X is greater than 0. A real number X is negative if and only if X is less than 0. A real number X is non-positive, so not positive would be either equal to 0 or less than 0 if and only if X is less than or equal to 0. And a real number X is non-negative if and only if X is greater than or equal to 0. Example 1. Okay, find the truth values of the following statements. One. If x is greater than 3, then x is greater than or equal to 3. Is that true or false? Okay, if x is greater than 3, then x is greater than or equal to 3. That's true. Number 2. If x is greater than or equal to 4, then x is greater than 4. Is that true or false? That one is false. What's the counterexample? The counterexample is x equals 4. Okay. Okay, number 3. If x equals 3, then x is greater than or equal to 3 is true. Is true, right? So if x equals 3, then x is greater than or equal to 3. That is true. Number 4. If x is positive, then x is non-negative. If x is positive, then x is non-negative. Is that true or false? Okay, that is true. That is true. What we're saying here is that x is greater than 0 implies x is greater than or equal to 0. That is a true statement. If you have a strict inequality, then you kind of get the compound inequality of x is greater than 0 or x is equal to 0. We kind of get that one for free. Okay. If x is less than 2, then x is less than or equal to 1. If x is less than 2, then x is less than or equal to 1. Is that true or false? That's false. What's the counterexample here? It's anything between 1 and 2. So like 1.5 is a counterexample. Number 6, if x is greater than or equal to 3, then x is greater than 3. Is that true or false? Yeah, I'm going to say that's false. And the counterexample is x equals 3. Okay, consecutive integers. The integers that follow one another, follow one after another. Okay, for example, okay, k and k plus 1 are consecutive integers if k is an integer. Okay, so like 3 and 4 consecutive integers. Okay, we could have 3, 4, 5. Okay, because 3 and 4 are consecutive and 4 and 5 are consecutive, so 3, 4, 5 are consecutive. Okay. Okay, and that is 3.1.